In the second part of this topic, we learned the meaning of the limit of a function as x approaches a. So now we know that if this limit is equal to the number L, it implies that the values of this function approach the number L as x approaches a. So now in this lesson, we are going to take an example of a function. So let's say we have to determine the limit of a function given by x squared minus 4 over x minus 2 as x approaches 2. Now after having this discussion, we know that in order to find this limit, we have to study the behavior of this function for the values of x near the number 2. So in order to study the behavior of this function, what we'll do is that we will take a few values of x as x approaches 2 from the left side as well as x approaches 2 from the right side, and we'll calculate the corresponding values of this function to guess the limit of this function as x approaches 2. So let's see how. You can see here two tables, where in the first table I have taken the values of x when x is smaller than 2. That is, I have taken the values of x as x approaches 2 from the left side. So for example, starting from x is equal to 1.5, which is right here. So as the values of x get closer and closer to 2, for example, I picked the value 1.9, which is right here. And as the values of x get further close to this number 2, I have taken a few more values of x as x approaches 2 from the left. And to each of these values of x, I have calculated the corresponding y values, that is the values of this function according to this rule. So you can see here, as the values of x get closer and closer to 2 from the left side of 2, starting from x is equal to 1.5, so you can see as the values of x get closer and closer to this number 2, the corresponding values of this function starting from 3.5, they get closer and closer to which number? So they get closer and closer to the number 4. So I can write this as the values of this function, which is x squared minus 4 over x minus 2, approach 4 as x approaches 2 from the left side. And this is how we write x approaches 2 from the left side, by writing a negative sign as a superscript of this number 2, which shows that x approaches 2 from the left side. Now, what does this statement imply? It means that this number 4 is the left-hand side limit of this function as x approaches 2 from the left-hand side. So we write it symbolically as limit of x squared minus 4 over x minus 2 as x approaches 2 from the left side is equal to 4. Left hand side limit of this function exists because this 4 is a fixed number. Now similarly, in this table I have taken the values of x when x is larger than 2. That is, when x approaches 2 from the right side. So for example, starting from x is equal to 2.5, as the values of x get closer and closer to this number 2. So suppose I picked the number 2.1, and as the values of x get further close to this number 2, I have taken a few more values of x, and to each of these values of x, I have calculated the corresponding values of y according to this rule. You can see that as x approaches 2 from the right, the values of this function starting from 4.5 get closer and closer to which number? So again, they get closer and closer to the number 4. And we write it as values of x squared minus 4 over x minus 2 approach 4 as x approaches 2 from the right side. And this is how we write x approaches 2 from the right side symbolically, by writing a plus sign as a superscript of this number 2, which shows that x approaches 2 from the right side. Now we know the meaning of this statement. It means that this number 4 is the limit of this function as x approaches 2 from the right side. So we write it symbolically as limit of x square minus 4 over x minus 2 as x approaches 2 from the right side is equal to 4. Again, the right hand side limit of this function also exists because 4 is a fixed number. So we see that the left hand side limit as well as the right hand side limit of this function exists, and also it's the same number in both the cases. So it means whether x approaches 2 from the left side or it approaches 2 from the right side, in both the cases the values of this function x square minus 4 over x minus 2 approach 4. So that is f approaches 4 as x approaches 2. X approaches 2 includes both the cases, that is when x approaches 2 from the left side as well as when x approaches 2 from the right side. Now we know the meaning of this statement very well. It means that the limit of x square minus 4 over x minus 2 as x approaches 2 is equal to 4. So this limit comes out to be 4. Now let's quickly look at this limit graphically as well. So for that, I have here the graph of this function. So this is our function x square minus 4 over x minus 2. And if you remember, this is the same function that we discussed in the lesson number 1, 2 and 3. We discussed there that this expression can be written as x plus 2 when x is not equal to 2. And we had also seen that f of 2 is not defined. That is, when x is equal to 2, this function is not defined. And starting from this expression, how we arrived at this expression when x is not equal to 2 has already been discussed in the lesson number 2. So when x is not equal to 2, y is equal to x plus 2. And we know y is equal to x plus 2 represents a straight line. So when x is not equal to 2, in that case, this function behaves as a straight line. Anyway, this has been discussed already. Now let's quickly look at the limit of this function as x approaches 2. So we can see here clearly, as x approaches 2 from the left side, the points on the graph approach this yellow ring because the values of the function approach the number 4 on the y-axis. So this number 4 is the left-hand side limit of this function as x approaches 2 from the left side. And similarly, we can see that as x approaches 2 from the right side, the points on the graph approach the yellow ring again because the values of the function approach this number 4 again on the y-axis. So this number 4 is also the right hand limit of this function as x approaches 2 from the right side. So which means that the limit of this function, which is x square minus 4 over x minus 2 as x approaches 2 is equal to 4. So we have seen graphically as well as numerically that the limit of this function is equal to 4. Now I want to point out one thing here, and that is in the lesson number 2 we had seen that this expression is equal to x plus 2 when x is not equal to 2. That is, this is also x plus 2 when x is not equal to 2. When x is not equal to 2, that is when x is either smaller than 2 or larger than 2, in both the cases, these two expressions will give the same result because they are equal when x is not equal to 2. So while calculating the y values in this case, we could use this expression instead of using this expression because this expression is a lot easier to work with. For example, when x is equal to 1.5, so x is 1.5 plus 2 will give us 3.5. In this way, using this expression instead of using this expression, we can quickly calculate the corresponding y values. Now in the end, I would like to mention that this method of determining the limit of a function as x approaches a will rarely be used in our coming lessons. Making tables of values of x and y is a tedious job, and also you'll see that if we will not take the appropriate values of x, it will not give us the correct answer. And also we don't know where to stop calculating the values. So this is not a very reliable method of determining the limit of a function as x approaches a. It's just guesswork. And I decided to discuss this method in this lesson so as to get some intuition of what really goes on when we take the limit of a function as x approaches a. So in my next lesson, I will discuss a method which is reliable and a lot easier to work with.